My name is Jenny Heinzen, and I'll be talking about the basics of wind energy. The audience is specifically supposed to be for women, but really anybody is invited. So small wind turbines, big wind turbines, how they work, some of the issues, grant opportunities, site assessments, anything and everything very broadly about small to large wind. Sustainability, I think more than anything, for me it's a matter of pollution, really, that I seriously doubt the human race is going to stop using electricity. So as long as we continue to use electricity, we produce it in a way that is clean and does not harm the environment. The idea behind the workshops for women is that, traditionally this is a male dominated, anything electrical or dealing with the trades a lot of times is male dominated, and we wanted a place where women could come and ask questions, maybe not be as intimidated or feel stupid, which you shouldn't. Nobody should feel stupid about asking any questions, but welcome. I've been a member of the MREA since the very beginning. I do solar installation workshops, I do wind installation workshops, and I still dabble with my electrical code and electrical issues as well too. I'm also president of Renew Wisconsin, which is a Madison-based organization that tries to push more aggressive renewable energy policy in the state too. So I'm a techie and a sparky, but I've also got into politics. I don't know how or why, but it's part of the game, and I like talking about that kind of stuff too. So what I put together here is very broad. We don't go real deep with a lot of these subjects. We're just kind of covering some ground from beginning to end about wind power. If you have questions, feel free to ask them as we go. Just make sure you raise your hand and we do it in an orderly fashion. If it's something that I'm going to be expanding on a little bit later, I'll say hold that question that's coming up. Otherwise, more questions at the end. Hopefully we have plenty of time. Okay? Any questions before we get started? The real basics of energy. Energy 101, as I like to call it, because sometimes people miss this point in school. You can't make energy, okay? You can transfer energy from one form to another form, but you can't make energy, you can't destroy energy. You can only transfer it from one form to another, right? We have heat energy, light energy, mechanical energy, electric energy. So the idea behind a wind turbine is that we're taking the movement of the wind, the force of the wind, having that spin mechanical rotors that then in turn change that to electrical energy. So every time you go from one form of energy to another form of energy, you lose a little something along the way, and that's called entropy, if you remember from physics or some other sort of science class that you may have had in the past. But right, we can't make electricity, we can only transfer it from one form to another. And traditionally, most of the electricity that we use, with the exception of people who live off-grid, electrical utilities use things like coal-fired plants and nuclear plants and natural gas plants. And the idea behind, could you turn that down a little bit? Thanks. The whole idea behind renewable energy now is that we're using things that don't pollute, right? The wind, the sun. We cut out the middleman, basically. That's the way I like to think of it. Wind and solar is pretty simple because you don't have to, like with coal, you got to get the coal out of the ground, and that causes a lot of environmental hardships just doing that. You got to mine the coal. Then you got to transport the coal on rail cars or trucks, however it needs to be transported. That's another issue. Then you have to burn the coal, pulverize the coal. That burning coal then boils water, produces steam, and then ultimately in the coal-fired power plants, it's the steam that drives the turbine. And a turbine, you can think of it like fan blades. That's all a turbine really is, okay? So we go through a lot of steps to eventually create electricity from burning coal. Natural gas is sort of like a jet engine on steroids. It's natural gas mixed with air, and but still we have to get the gas out of the ground. Okay, natural gas is found in the same pockets where we find oil, so we're talking about mining and drilling issues. Transporting it, pipelines, whatever it might be, to finally burn that gas to push the turbine and create electricity. Nuclear power, sort of another beast. Uranium is not renewable. You need to mine uranium out of the ground, and as you guys are probably aware, there's some problems with storing the spent fuel. Once your fuel is no longer usable, so to speak, as nuclear power, then you've got to store it somewhere, and that's a big issue with nuclear. But that's still a steam-driven turbine. The uranium, when uncovered, gets hot, and that makes water boil and produces steam. Wind power, look how simple. And you can see it, right? If you look at a wind turbine, there's the turbine. You're not doing anything else to get that turbine to spin. It's the wind that naturally makes the turbine spin. So it's simple. It's very simple technology in that respect. Now, how it works is actually kind of simple as well, too. How many people have been on an airplane in their lives? All right. Airplanes used to scare the crap out of me before I got into wind energy. How do you get this giant, I don't know how many tons of steel off of the ground and flying through the air? It's all done through airfoils. I like telling people, and I'm guilty of this until I hit a bumblebee on my arm, but when you're driving on the highway and you stick your hand out the window and you're going up and down, you're making lift and drag, right? And now I love airplane rides. I always get a window seat right next to the blade so I can watch as it feathers and it does its thing throughout the flight. The science of lifting has been around since we figured out how to get airplanes off the ground as well, too. And birds, hey, birds figured this out a long time ago as well. Drag devices, this is the old-fashioned water pumping windmill. Those are drag devices. That is simply being pushed by the wind. Okay? Same as, if you have a jacket on a windy day. We used to do this when we were kids, kind of unzip your jacket, put it up around your head, and you get pushed back by the wind. Those are drag devices. That's not what wind turbines use. Wind turbines use lift. Okay? Windmills use drag. Wind turbines use lift. So that's why you see a whole lot of blades on the drag device, but very few blades, usually only 2 or 3 blades on a wind turbine. Okay, we don't want all this taking up our space. This is called solidity. This is a high solidity, a lot of area in the circle being taken up by materials, whereas we don't want that on lift devices. So wind turbines do not use drag, they use lift. Just like an airplane, what happens, here's the theory, very, very simply put, is that if you have a certain amount of wind or air coming from this direction and it splits off and goes around this airfoil, it has a longer distance to travel around the top of the airfoil than it does going underneath the airfoil. So this causes a pressure difference between the top and the bottom, and it actually pushes up, because this has a lot more to go and the density pushes it up. So if you understand how the basics of an airfoil work, then you understand how wind turbines work as well. Just as a little bit of humor here, I stole this slide from a friend of mine from North Carolina who also teaches wind. Terminology sometimes, people refer to wind turbines as windmills, and they're not. Windmills pump water, windmills crush grain. This is a turbine. This is a turbine. But it sort of depends, I've noticed too, on what area of the country you live in, whether you call it a turbine or a turbine. But they're not windmills, technically. Technically, they're not windmills. How much power you can get out of a wind turbine depends on a couple of things. And this is constant. This never changes. I don't care what the design, 2 blades, 4 blades, 12 blades. This is how you can determine how much power comes from your wind turbine, or power from the theoretically perfect wind turbine. The power is found by taking 1/2 of the density of the air, and there's a couple different variables that go into the density of air. For example, the temperature, the humidity, and the altitude. Okay? Take that number and multiply it by the area, which is the circle. Okay? The blades are going to be going through a circle, so that's the area. We call that the swept area. Maybe you heard Wind Geeks talk. We talk about swept area. That's that number there. And the really important part of this equation is V cubed, the cube of the wind speed. Okay, so if you're going to change anything in this equation to make more power, what would be the easiest thing to do? The most effective thing to do? Wind speed, right? Yeah, you can increase the swept area. Sure, you could get it on a different, elevation. But ultimately, if you want more power, just that 1 mile an hour or 2 mile an hour extra that you can get by putting that up on an extra 20-foot tower section will give you that much more power. That's why wind turbine towers must be tall. 20-foot, 30-foot wind turbine towers, unless you live on a ridge in Wyoming, just aren't going to work. Okay? Take a look at the wind turbines we have here on this campus, right? 100 feet, 120 feet. That's where the wind is. That's where the good wind is. Good example of humidity today, right? Humid air is a lot more dense than dry air. So actually, D went up for us today. That's good. I don't know if it's good, but I can feel it. As temperature goes up, what do you think? Does that increase or decrease the amount of power that we could make? What's more dense, hot air or cold air? Cold. Cold air is more dense than hot air. So actually, what we would like is cold air, humid air, and not necessarily in the mile-high city like Denver, because the higher the elevation, the less dense the air gets. So if you took two exact same wind turbines with the exact same wind resource, with the exact same area, put one in, say, New Orleans, put the other one in Denver, the one in New Orleans would outproduce the one in Denver by a little bit because density has changed. So this is a constant. You can always figure out, if you have these numbers, how much power theoretically a wind turbine could make. Don't bother putting up a wind turbine or think about putting up a wind turbine, though, unless you know that you have a good wind resource. Okay? Not, what does Mixagrilla call it, the wet thumb method? Yep, it's windy here. But an actual site assessment. Not just looking at the state map. If your state has one, it says, oh, there's good wind here and not so much there. Not just taking a look at that picture of the state map, but an actual, what we call a micro siting on your property. You have trees, you have houses, you have prevailing winds, you have different things that can come into the mix. And in the state of Wisconsin, you can't even get grant money unless you have a certified site assessment done first. It's a production-based incentive. So in other words, Focus on Energy in Wisconsin will give you money and help you install it, but only if you're actually going to produce something. Okay? Unfortunately, what happened was, like, at the end of the 70s and the early 80s, people started putting up solar panels and wind turbines, and they weren't put up well, and they weren't put up in places where they could have been put up to produce well. And then what happens is we get this really bad public perception of, hey, wind doesn't work. I've seen this windmill up on the hill for 10 years. I've never seen it spin. Well, that was sited poorly, or it's broken, or someone's not maintaining it, you know? Yeah.
With the Focus on Energy, you, for a wind assessment or a site assessment, if you just call their 1-800 number, they will send you vouchers to help you pay for your assessment.
Yep.
You can get up to $150. And that's the first thing the person says to you when they come on site. You got your vouchers, and then you just pay the difference.
Good.
So before you even hire somebody, get those.
Get the voucher. It's a coupon, basically.
Yeah, it's a coupon.
Thank you.
It's a state.
Thank you.
Paid for.
How many of you live in Wisconsin? Raise your hands. Quite a few of you. Okay, so Focus on Energy is a place, if you've never heard of Focus on Energy, probably the first place you should check out, besides, of course, the Energy Fair, the MREA. They are. Very good. And they're the people that have the money, too, so you want to make friends with them. Yeah?
That's very much the first step, and when the assessment person comes, they do a lot more than just, you know, if your question is about your wind, they will assess a lot of your property for other things, too, so
Right.
you have a better idea.
Right.
They'll even walk through your home and see how you could save energy.
We do that as part of a good site assessment. We always make sure, you know, because usually people are well educated. If you're thinking about renewable energy, usually people have done their homework ahead of time, and they're aware that the 20-year-old fridge needs to go, and the incandescent lights need to be changed, and things like that. But we still want to make sure. Home Power Magazine recently had an article. They talked about for every dollar that you spend to just, you know, to make your house more efficient, you know, that's like 3 times more valuable. You know, there's like $1 to $3 difference between doing efficiency stuff, which I'll admit is kind of boring. You know, who wants to put insulation in the house and buy a new fridge? You know, I want a windmill. But you're going to save a lot more money. It's a much better return on your investment by becoming efficient first. Very good points, ladies. Thank you. Yeah, not everybody lives in Wyoming. This is a Wyoming windsock. If you've ever been to Wyoming, you know what I'm talking about. Trucks tipped over. Yeah, this right there is a gentle zephyr, I think the sign says right there. It's a lot of wind in Wyoming. And Wisconsin is number 17 on the list out of the 50 states. So we're not the windiest state, but we do have good spots, good patches, good sites of land where you can use wind energy effectively. We're also not the solar capital of the world, but solar can work. You know, you can make it work. Don't put it on the north side of the house. Get a good site assessment done, but it can work. A little more rudimentary, but sometimes the vegetation can give away whether or not you've got prevailing winds that come in a particular direction. If you live along like a coastline or along Lake Michigan, we see a lot of our trees along lakeshore of Lake Michigan that kind of have a little bit of this going on. They're growing more on one side than the other. The prevailing winds from the west always seem to be kind of tilting the vegetation over. It's just something, I'm an electrician. When I walk into a building, I'm looking at lights, I'm looking at outlets, I'm looking at wires. When you're a wind site assessor, you drive around looking at trees and things like that, and which way things are growing. Wind speeds increase with height, right? Remember that equation I showed you, the cube of V? Okay, this is how important it becomes. A 30-foot tower, I mean, yeah, the blades will spin, but it's not going to make nearly as much power, and that's what we want, right? Energy, kilowatt hours, coming out here and here and here and just increasing. V cubed. If V was 2, what's the square of 2? 4. What's the cube of 2? 8. So if you can increase your wind speed 2 miles an hour, you can get 8 times as much power out of that machine. That's how important V is. And that's why tall towers are so important. Okay? Sometimes the zoning people in your county or your village aren't necessarily hip on 120-foot towers. They say, why can't you just put this on a 50-foot tower so people don't complain? Well, because that's going to, decrease the amount of energy that you can produce. How many people in this tent, I was going to say room, but it's a tent, pay attention to not only the dollar amount that you're writing on the check to the electrical company, but the kilowatt hours that you consume each month? Raise your hand and be proud about it, because if you're doing it, you're one of the few. You actually watch how many kilowatt hours you use every month. That's probably one of the most important things to keep in mind. The less you use, the less you have to make. Okay? And you have to be a little bit careful in this wind industry world, because companies will call their machine a 10 kilowatt machine, a 7.5 kilowatt machine, a 50 kilowatt machine. That doesn't really tell you very much. You need to know how many kilowatt hours that machine's going to produce, and then match it, or if that's your idea, to try to match it to what you're actually consuming. And we're going to talk more about that in just a little bit. Just as an example to prove my point that taller towers are better, this was taken directly from the Jacobs behind us here at the MREA. I mean, it's from 2002, but I could grab a chart from 2008. It would say the exact same thing, that the anemometers at 86 feet are showing higher wind speeds than the ones that are at 46 feet. This is just the nature of the beast. This is the way it goes. Get that turbine as tall as you can get it. Sometimes people balk at the cost of the tower. The tower is probably the most expensive part of the entire installation. It's steel. It's 100 feet of steel. So they look at the price list and they go, whoa, give me the 60-foot tower. I can't afford the 100-foot tower. But what does that do to you in the end? It decreases the amount of energy that you're making, which makes your return on investment, a longer period of time, which makes the sticker shock a little bit more, it's going to take me 20 years to pay this thing off. If you put it on a 100-foot tower, maybe you could cut that time quite a bit. The other misconception that's out there is that, well, I've got this old silo in the back of the lawn. I'll just go put this wind turbine on the silo. I'll put the wind turbine on an antenna, a TV antenna that's on the side of my house. Keep wind turbines away from any sort of turbulent winds. I talk about if you're walking downtown to get a cup of coffee on a Saturday morning, and the coffee shop has a flag hanging outside the front, and it's a windy day and there's wind tunnels on the sidewalk, and that flag is just flipping left and right and circling all over, that's turbulent wind going in all sorts of swirly directions. You don't want that for a wind turbine. Okay? First of all, on a mechanical standpoint, it will wreak havoc on the machine. Okay? And secondly, that's just not where the good wind, you want what pilots call laminar wind flow, a nice, straight, clean fetch of wind coming in one particular direction. You don't want wind swirling around buildings and up around roofs or anything. Keep it away. Here's a rule of thumb. I don't have it written down anywhere, I don't think, so you might want to write this one down. When you have a wind turbine, let's say that they're going to put a wind turbine on this land, the bottom of the blade, right, say you have a 3-bladed machine. So one of your blades is facing, straight down at the ground, 6 o'clock. Keep the bottom of that blade at least 30 feet above anything within a 500-foot radius. Keep the bottom of that blade at least 30 feet above anything within a 500-foot radius. 500-foot radius, yep, 30 feet above anything within a 500-foot radius, absolutely. That will assure you are out of any turbulent zones. Now keep in mind, in this picture, the prevailing wind is coming from this direction. What if the seasons change and now the wind is coming out of this direction? Okay? So let's say, for example, the homeowner thought, well, look at this. This is my turbulent zone. I'll put my wind turbine right here. What if the wind switches direction and now the winds come out of this direction? Now your turbulent zone is right there. 30 feet above anything within a 500-foot radius. Rule of thumb. No. Turbulent winds, this is photoshopped, this is not real. Turbulent winds, and also if you're even considering mounting a wind turbine on a structure, that structure is going to experience a lot of rattling, shaking, not good for the structure, and it will be noisy. You know, you wouldn't be able to live comfortably inside of a building that would have a wind turbine mounted on the top of it. You would hear it shaking, rattling, and rolling all the time, if it even worked. Okay? Vibration, turbulence, structural integrity. We categorize, and I keep it in quotation marks because there's always exceptions to the rule, but in general, when people talk about small wind turbines, they're talking about like a residential size. You know, I want something that could power my home. That's what we refer to, and smaller, as small wind turbines. And then what I call medium wind turbines are the ones that are a little bit bigger, maybe for a farm, maybe for a small business, that don't make the same as the big, large utility scale wind turbines, but like the one at LTC that makes, 5 homes worth of electricity. Something a little bit bigger than small, but not quite as big as big. Most of the wind turbines in the medium category are actually old turbines from California. That's where we got our machine as well too. Back in the 1980s, wind turbines were installed in California, and they were rated at like 65 kilowatts. And then along come these big 2 megawatt machines, so they're being replaced, and all these smaller machines are being remanufactured. So our turbine on our campus actually ran for 20 years before it came to us. These machines can last as long as you take care of them. How long would a car last if you drove it off the lot and then never paid any attention to it whatsoever? Never checked any fluids, never changed the oil, just drove it. No new tires, no new anything. It won't last very long, right? But somebody who takes good care of a vehicle, you can make that last for a very long time. Unless you live in Wisconsin and you've got rust all over it and the body falls apart when the engine still runs. It's another story. So large-scale utility is like wind farm equipment, 2 megawatt machines, really big machines. I took this picture because this was out in Iowa somewhere. It was a wind farm, obviously, a big wind farm, but then there was a business right around, down the street that had this, 20 kilowatt machine off in the distance too. It was kind of a perfect little best of both worlds right there. So just to give you a sense of scale and how big really is, Jacobs 3120, that's what's out in the parking lot. Okay, so that's about a 120-foot tower usually. Yep, 120-foot tower. Vestas, this is what we have on our campus at LTC. And this is what the MATC Mequon campus has. If any of you are from the Milwaukee area, you know where Mequon campus is probably. That's their machine. And now this is wind farm equipment. This is the bigger stuff. And there's even 2 megs and 2.2 megs that are bigger than this picture right there. So as a sense of scale, they're quite larger. Yeah?
It seemed to me that windmills, by contrast, were able to move with the wind as it changed directions. But these turbines are more statutory, and they depend on wind coming from only one direction.
Actually, all the wind turbines will change as the wind changes direction. They do. The small wind turbines, like the residential wind turbines, I think it's one of my next coming slides. Yeah, say this is a small wind turbine, the tail will naturally orient itself in the right direction. Or you could have a downwind machine that doesn't have a tail, but it spins the machine out of the direction of the wind. You can take it from the front or from the back, upwind, downwind. And the big machines, there we go. The really big machines, what they have in here, it's a sailing term. If anybody sails, you yaw. Have you heard of yawing? You pivot or you change direction. There's a yaw drive on these big machines. Sensors, wind vanes, anemometers send an input to the computer at the base of the tower, say the wind is coming out of the west-northwest. So the yaw drive mechanism, it's a motor and it spins the machine to where it needs to go. So the machine is always facing into the wind or out of the wind if it's a downwind machine. So yeah, they do definitely change position as the wind changes position. Great question. Okay. Oh, yeah.
When it says 20 kilowatts or 35 or whatever, does that mean 20 kilowatts, that's the most it can make in an hour or in a day?
You asked it at the perfect time. This is the slide around right now. I wanted to go back to that kilowatt hour thing we were talking about. If you pay attention to how many kilowatt hours you use on your bill, that is more important than anything, kilowatt hours. Okay? When a machine is rated at 35 kilowatt, 50 kilowatt, that doesn't mean much to you or me, all right? That is a nameplate that the manufacturer has given that machine. For example, this is our turbine on our campus. The red line is the one that we have. Ours is called a 65 kilowatt machine. So 65 kilowatts is right here up on the scale on this side. And what that means is it will make 65 kilowatts when the winds are about 32 miles an hour. So no, it doesn't always make 65 kilowatts. No, it doesn't make 65 kilowatts in an hour. You know, none of that, which you would think, doesn't apply. What it means is that the machine will make 65 kilowatts at a particular wind speed. That company could have easily called their machine a 30 kilowatt machine. It makes 30 kilowatts at 18 miles an hour. The company can call it whatever they want to call it. Wind, unlike solar, is a buyer beware market. Because you could have one machine completely outproduce the other, but you know, they call themselves a 20 kilowatt and the other one was only a 10 kilowatt. You can make it sound better than it really is. One of the biggest challenges for the small wind industry right now is getting that standard. When you buy solar panels, PV panels, they're 200 watt panels, they're 250 watt panels. That's at 20 degrees Celsius. That's at, 1,000 watts per meter square of sunlight. That is standardized test conditions where those PV panels, so a consumer can shop around and say, well, the Kyocera is this much and the BP is that much, and they're still going to make that 250, watts. Wind power is not the same way. What you want is this power curve, okay? Power curve. And also the manufacturer should give you an estimated annual energy production, kilowatt hours. How many kilowatt, and this is why the site assessment is so important. When your site assessment is done and your site assessor comes back and says, you have an average of 12 mile an hour wind speeds here. Your average annual wind speed is 12 miles an hour. Now you can go shopping. Because now you can take a look at the other, turbines that are out there and say, okay, my average wind speed is 12 miles per hour. How many kilowatt hours can I make if my average wind speed is, that much? Now you can shop as an educated consumer. But also, that's what the manufacturer is telling you. Do you think manufacturers would lie to tell you how many kilowatt hours they make? My advice is, say you're doing your homework and you've decided I'm going to go with the Berge machine. I like the Berge XL. I'm going to get a 10 kilowatt machine. Go find people who fly Berges, who own Berges, and talk to them. Most people who own this equipment are more than happy to share with you the good, the bad, and the ugly and how much it makes. Yeah. For the wind speeds and the kilowatt hours, yes, they do. But don't trust them 100%. Look at them. Shop with them, but I really think you should talk to someone who's got a similar machine as well. Yep, they have power curves, they have energy curves. In their manuals, in their product pamphlets, they should have all that stuff in there for you. Other people? Oh, Focus on Energy. If you live in Wisconsin, Focus on Energy would help you with that. Yeah. Or drive around until you find one. No, I'm kidding. Yeah. For those of you who are staying for the full weekend, I'm kind of disappointed they set it up this way, but I'm also teaching a class on Sunday morning, Basic Electricity for Women, where we're going to talk a lot about what's the difference between power and energy and watts and volts and amps and all this kind of stuff. It'd be nice to kind of have that before we get into this, but that's okay. Buyer beware. That's the point of my little spiel there. Buyer beware. Watch the kilowatt hours. On a small wind turbine, very simple technology. The blades are mounted to what we call the rotor, and the rotor just means it's the spinny part of the machine. So you got the spinny part of the machine. Here's the coil of wires and the magnets and everything that are going to spin together and ultimately produce electricity. That's on a small machine, we just say it's the generator. On a big machine, we'll call it the nacelle, and I'll get to that slide in just a moment. And the tail, we were just talking about tails, and now that naturally orients the machine in the right direction. This would be an upwind machine. If it's an upwind machine, it has a tail. If it's a downwind machine, it does not have a tail. And then, of course, you need the tower. You need the thing to stand up on something, so you need a tower. So, very simple design. Upwind, downwind. Some machines are designed to face out of the wind. That's called a downwind machine. Some machines are made to face into the wind. That's called upwind. Okay? Small upwind machines usually use tails to orient themselves in the right direction. Large upwind machines use computers and yaw drives and motors and things like that to get the machine to turn in the right direction. More complicated. And of course, we want the turbine to be able to not only figure out what direction the wind is coming from and orient itself in the right direction, but it also needs to protect itself in case of high winds. God forbid some sort of nasty weather event comes through this weekend, that turbine's got to be able to shut down, okay? Ours shuts down at 55 miles an hour. I believe the two Jakes here are somewhere around 50 miles an hour, and they're going to, what we say, govern themselves. Get out of the wind, okay? And it depends on what machine you have, which manufacturer it is, but some of the machines will furl, okay? That's another sailing term, furling. This is a picture of a machine that furls backwards. The whole idea here is that instead of the blades being into where the wind is coming from, facing in those prevailing winds, get the blades out of the wind. In the case of the tilt back, now the blades are parallel with the wind, and hopefully the wind just kind of zips right over the blades. Many machines, like the Berge and the Jacobs that are here, they side furl. There's like a hinge mechanism in the tail, and the blades will actually turn. So now again, the wind is just going over the blades, parallel the blades, and not facing into the wind. So that's the way these machines govern themselves. Some machines like the Proven and the really big wind farm equipments, the blades will actually change their pitch. Lift drag, remember we talked about lift drag? They'll actually change the pitch of the blades so that they're not lift mechanisms anymore. Now they're drag. They can stop, they can start, they can speed up, they can slow down. The really large machines, all computer driven. All computer driven, all those blades will feather in and out as needed.
Does that mean when you drive past the wind farms and none of them are moving, that's probably why?
It could be a number of things. It could be, well, the winds are too strong, but that takes like 55 miles an hour for that to happen. Sometimes they're going through tests and commissioning. Sometimes there isn't enough wind to get them to get started. There's a lot of different reasons why you see that. Yeah.
I know we went through on a windy day and we're like, why aren't they moving?
If it's too windy, they'll shut down. Yeah, yeah. And even though it might not feel too windy on the ground, remember those nacelles are 250 to 300 feet above the air, where if you don't believe it's windy, the taller you go, sign up for one of my classes. I'll climb you up that machine. Because the students, it's so funny, especially when it's springtime, right? We had a 10-month winter and everybody's ready to wear shorts and t-shirts. My students are out there in shorts and t-shirts, and it's nice on the ground. It's like 60, 65 degrees. I said, you guys got sweatshirts, right? You're gonna put on sweatshirts. Oh, it's nice outside. All right, lesson learned. Got about halfway up the tower. Ooh, it's cold. I should have brought my sweatshirt. Okay, the wind speeds really do pick up quite a bit as you climb. Even 20-foot sections, you can notice it as you're on your way up. Coning. Coning is something that the downwind machines would do. Guys ever play badminton, seen a badminton cone? It looks like the birdie, right? Is that what they call it? The little rubber top and the birdie. That's sort of what like the Proven machine does, is it's a downwind machine, so the wind's coming at you from behind, and if it gets too windy, the blades actually kind of cone inward, and that decreases that swept area, that gets them out of the wind, so that's what naturally makes the machine slow down. And then on top of that, you can actually put brakes on machines too. You can have electrical brakes, you can have mechanical brakes, disc brakes, hydraulic brakes, just like you have in your car. You can have centrifugal tip brakes, which means like the tips of the blades kind of pop out and stop the machine from spinning too fast. But all wind turbines have a way of protecting themselves and getting themselves in the right direction. We call that governing. The machine knows how to govern itself. Typically, these small wind turbines, again, are something for residential use, and nameplate-wise, that's usually 20 kilowatts or less. They can be connected directly into your existing electrical system in your home. That's probably the most popular way of hooking up wind turbines and solar panels, because most of us live, with electric lines from the utilities coming into the house. It's really not that much different than hooking up a new dryer or a new range. Electrically speaking, I'm an electrician, so I can say this, it's really not too difficult to get the output of that turbine to connect to your electrical service in your house. You need a box, though, called an inverter that makes the electricity the right voltage and the right frequency and all these things we'll talk about Sunday morning, sorry. But since the wind is always varying in speed, that means the output of this machine is always varying in speed, right? Wind speeds increase, you make more power. Wind speeds decrease, you make less power. The inverter box then needs to make sure it's always 240 volts, 60 hertz, communicating, synchronized with what's in the rest of your house. They could also have batteries. Anybody in the room here live off-grid? Any off-gridders in here? No? Sometimes people, don't have a connection to the electrical utility, so they use batteries, and they make their own power. So it can be used and connected in that way too. You can be grid connected with battery backup. You know, you decide if you live in a part of the state where the power goes out all the time and you need power, you could get battery backup. But just be aware that it increases the cost of your installation. Batteries are an ongoing maintenance. You can't just, again, like driving the car off the lot and leaving it alone. Got to take care of the batteries, and they are kind of expensive. You can expect to pay, everybody, one of the first questions I get on the phone all the time is, how much does one cost? It's such a hard question to answer, and it's not because I'm trying to avoid the questions, because there's so many variables. Do you participate and focus on energy? Does your electrical utility have special buyback rates? Do they participate in net metering? What wind speed? What's your wind resource at your place? What kind of tower are you planning on getting? There's so many questions that go into this. I just give a ballpark. It could be $10,000. It could be even higher than $75,000. It could be $100,000 if you wanted to spend, you know, a Pinto or a Cadillac. You know, how much does a car cost? Depends on what kind of car you're buying. Okay. Don't forget too that focus on energy, and also now finally at the federal level, there's grant money to be had. Okay? Focus on energy, 30%. Federal grant, 30%. Okay? You can get 60% of your machine or your solar panels paid for right off the top through state and federal grants. The medium-sized machine, this is a picture of the one we've got on our campus, is a lot of times referred to as a commercial or an agricultural-sized machine, somewhere between a nameplate rating of 20 kilowatts up to 660 kilowatts. Very rarely do you see batteries connected. You don't see this kind of stuff off-grid. This is straight grid connected. Could be $50,000, could be $1 million. Depends on what you get and what your grant money is and how much money the utility is going to give you for electricity. They're typically almost always upwind machines. And I talked about this already, that a lot of times they're the used, what used to be big machines back in the 1980s. They're now being remanufactured by a couple companies in the United States. And then there's wind farm equipment, big wind. I love big wind. I think it's really neat. 2 megawatts, 2.2 megawatt machines, either owned by a developer or owned by a utility. The electricity being produced is being sold, you know, bought and sold like a commodity. Lots of fun, very expensive, but these things pay for themselves very quickly. Okay? A small residential wind turbine, depending on how much you pay, you're probably looking at somewhere around 10 years to pay for the machine, to pay it off, okay? That's just complete ballpark. It's like buying a car but not having to pay for the gas, right? The fuel is free, but the machine still costs money. Again, it's the tower which is most of the installation cost. The tower, the foundation, the machine, the installation, the wiring. Whereas with the large machines, you're looking at usually like a 2-year payback on these things. You know, companies like GE wouldn't be investing in wind turbines if they had a 20-year payback. That would not be in their, you know, quarter-by-quarter financial way of doing business. So actually, as odd as it seems, the larger the machine, the better investment it is. The more, well, the faster it'll pay itself off. So large machines, again, they've got a rotor. Blades are attached to the rotor spins. But now what's different than the small machines is that you usually have some sort of a big gearbox in between the rotor and the generator. So if you notice, when you drive past wind farm equipment, it looks like the blades are going really slow. Okay? Well, for every single rotation here, there's actually 100 rotations or more going on the other end. There's a gearbox in between with a 100-to-1 ratio or a 120-to-1 ratio. So even though it looks like it's going really slow on the outside, by the time it gets through that gearbox into the generator, she's spinning fast, real fast. And these machines have to go slow because the blades are 120 feet long. Okay, there's just something in the physics about, you know, going really fast when you've got a, you know, 4-ton blade clipping along at 1,200 RPM. Doesn't work so well. So, I mean, they're not that different than the small machines, other than the fact that a lot is computerized and motorized, and it's a much longer climb. You're pooped out by the time you get to the top of one of these. How am I doing on time?
It's 11:40.
It's 11:40, so we have like 15 minutes and then this question. Okay. There are different types of towers out there. There's guy wires. Type of towers. There's lattice-style towers, which is what this is, crisscross angle iron. There's tilt-up towers. You could have them tilt up or down. Or you can have what most large wind turbines are on, which is a monopole. just a tube. In fact, we make those where I live in Manitowoc. There's a company called Tower Tech that takes 2 1/8 inch rolled steel and makes these big tubes. And you see them going down the highway on the trucks, and it's pretty neat. It's pretty cool. We're the #1 consumers of steel right now in the state of Wisconsin at Tower Tech in Manitowoc. We use more steel than any other manufacturing facility in Wisconsin right now. Tilt-down towers are for those who don't like to climb. They're not simple. Do not think for just a millisecond that this, oh yeah, I'll get a tilt-down tower, piece of cake. I'll get some friends over on a Saturday afternoon, we'll tilt this sucker down. Bad things can happen on tilt-down towers, okay? I speak from experience, I've seen it happen. You need an experienced crew. You need to make sure everybody knows what they're doing. It needs to be a controlled lower, okay? And raising it back up again. It can be scary. It can be really scary. I mean, put 600 pounds on the top of a 120-foot stick and try to very slowly, gradually tilt that down. It's not very simple. I personally prefer to climb. I would much rather climb than tilt something up or down. And then there's this new technology, upcoming, latest, greatest technology. I say that sarcastically. Vertical axis machines, instead of spinning on a horizontal axis, around a horizontal axis, these spin around a vertical axis. And there are a few designs out there that are showing some promise. There are a few. Most of them don't bother. They look neat. And if you go on the internet, there's a lot of stuff all over. Buy our product. It's only $2,000. It'll power your house. If it sounds too good to be true, it's too good to be true. Okay, it usually is. Of course, you know, we played with this technology again back in the 1980s. I don't know if you can tell from the picture here, but that's a truck. That's a pickup truck. This is a big vertical axis turbine. They call these egg beaters because they look like, you know, egg beaters. There's a lot of stress points on a machine like this. The advantage, of course, you don't have to climb. All of the controls and everything are at the base. The machine doesn't have to yaw or pivot to get in and out of the wind. It can accept wind from any particular direction without moving. You know, for that reason, it sounds like a great idea. You can see some guy wires keeping it steady here. The problem is when it really starts to spin, all this centrifugal force that's on the outside really starts to pull the machine apart. And you've got these pivot points that are supposed to hold everything together. And this particular wind farm, I think, was in Canada. It lasted about a year, and then the maintenance costs just got out of control. And the company shut it down because they couldn't afford to maintain them anymore. It was too much. So right now, I mean, I'm not opposed to new technology. I think new technology is great. But we know what works, and we know what works well, and this is what works well. Horizontal axis machines, 3 blades work great. Yeah.
Aren't they good for turbulence? The other type of...
They can still be affected by turbulence just like a regular wind turbine would. Mm-hmm. Yeah, they're still spinning, you know, they're still mounted, so therefore they would still be affected by turbulence. Yeah. And I've never worked on a vertical axis, so I can't tell you exactly how, like what parts shake and rattle, roll more, but anything that spins is affected by turbulence. Yeah. We had at a seminar a while ago, we had a salesman who was trying to convince our group of people, which was, you know, kind of the wind industry in general, that his vertical axis turbine was better because normally you see vertical axis, you know, mounted like this. And he said his design was a lot better because they were putting them on rooftops like in Chicago and New York. They were taking it and they were kind of taking the whole thing like that. So it was still an egg beater, but it was spinning. He said, so it's a lot better and it doesn't shake, it doesn't have vibration because we've mounted it horizontally now. And someone made the comment in the room about, oh, so if I took the engine out of my car and mounted it, you know, 90 degrees different, that means the engine wouldn't shake anymore. And yeah. Again, I'm not opposed. I'm not trying to sound, you know, like I'm belittling this technology, but right now it's not what works. And I really think we should concentrate on what we know works. Okay? My 2 cents. Okay? And the policy part of my life, what I'm going to end with is an area of my life I never thought I would get into, but for me, wind turbines are a no-brainer. They produce electricity. They do it without pollution. What's the problem? Not in my backyard. NIMBY. Have you ever heard of NIMBY before? NIMBY syndrome, not in my backyard. All sorts of issues have been brought up, at least in this state. Wisconsin, unfortunately, is one of the most notorious for NIMBYism when it comes to wind power. everything you can think of, and probably more things. I mean, stuff was brought up that I never thought of about wind turbines that people don't like. Kills birds, it throws ice, they're ugly. They're going to bring my property value down. Wind turbine syndrome, they'll make you sick. Lightning strikes, too much traffic, it interferes with radar, stray voltage on the dairy farm. Anything and everything that you could think of for someone to oppose a wind turbine has already been brought up in this state, guaranteed. Yeah.
Is there any, do they ground them? I mean, really,
Oh, yeah.
electricity is,
Absolutely.
lightning is the issue no matter what structure you put up.
Absolutely.
Do they have a solid grounding?
Yes.
Is
Yes.
There, I mean, is there something you should look for in a purchase with the grounding? Is there some that cheap out on that?
If it's a legitimate company, they have passed all of the UL standards. They are following all the electrical codes. They'll tell you in the user's manual that the rebar in the concrete must be bonded to the anchors. I mean, we ground the crap out of these machines. If we don't ground them, they're lightning rods.
Right.
Lightning will strike if you don't ground them, so you have to ground them and ground them well. Ground them well. And what we put in all the ordinances that I've ever worked on anyways, all installations shall follow national, state electrical codes. Cover yourself. It's grounded just in the same way anything else is grounded. More grounding, better. Absolutely. So there's a whole lot of that kind of stuff going on, and then I like to take a step back and say, oh, wait a minute, how ugly are they really? Just look at those eyesores. Yeah?
On a comment on the other slide, we're in the process of putting a wind tower up, and it wasn't the zoning, and it wasn't you know, the county or the city or the township, and all those boards you had to go to.
Yeah.
It was insurance.
Insurance.
And we had to refer them to Focus on Energy.
Good.
So they could get their facts straight, because they said, oh, we can't put, you can't put,
Yes.
you know, your neighbors are, you know, a half a mile away will get ice thrown on their houses.
I never thought of putting that on there. You're right. Insurance is another big issue we need to talk about.
Yeah.
Yeah. Thank you for bringing that up. Yeah. Yeah, that's true. Yeah.
Are any of your NIMBY things legitimate, or most of them?
There are some legitimate issues, absolutely. If not connected electrically correct, like everything else I was talking to the other lady about there, you know, follow all your electrical codes. Bat kill is actually pretty legitimate. Right now there's huge study going on why the big wind farms are killing bats. Bats are, for some reason, attracted to these machines. So bat kill is definitely legitimate. Now, aesthetics, you know, whether or not you find them ugly, that's all, you know, up to the individual. I think they're beautiful. Other people don't think so. Yeah, surprise, right? Attractive nuisance, do you know what that means? That's kind of legitimate. Kids are going to see it and they're going to want to climb it. So they're going to come, you know, like a swimming pool or a trampoline in your yard, you know, insurance reasons, they might have to put a fence around your pool or something. That's what attractive nuisance means. Oh yeah, communication interference. Sometimes, again, this is big wind, not small wind, but sometimes people are having trouble with their, it's not satellite, antenna, analog reception, thank you. But we're going all digital, what, next month or something? So that's, yeah. And what wind farm developers will do is they'll actually just they'll buy cable for you or buy a satellite dish for you or something if you have problems. And radar. This one just came out in the Milwaukee Journal-Sentinel about a month ago. All those wind turbines in the Fond du Lac area are showing up as storms on Doppler. There's always a thunderstorm in Eden. So what they're doing, they said it's easily fixable. They can mitigate it. They just have to tell their computer system somehow that this is fixed and ignore that, you know, and yeah. But it is funny. I mean, they were showing the Doppler radar, and sure enough was this big blue splotch of, you know, oh, that's the wind farm. So yeah, some of them are legitimate, but they get taken a little bit, you know, to the extreme. Yeah, yeah. Like anything else does. If you would like to know about state grants, incentives, insurance, which utilities are participating in net metering, who the good installers are in the state, all this kind of stuff, this is the website you want. This is probably one of the best websites, solar, wind, renewable, anything. DesireUSA.org. It should be on your sheet of paper. Just click whichever state you have questions about, and it comes up with a whole list of here's the grants, here's the state grants, here's the Fed grants, here's anything and everything you could possibly need to get rolling. Okay? And I think my time is up. Thank you. Yes, my time is up.
Thank you very much.
Thank you. Thank you.